case are we seeing right now? The first one, this one, where the object is at infinity, all the lights are going parallel, and they meet where? At the focus. So there's one more thing to notice over here. You can see a dotted line. See, there's a dotted line. What does it mean? Because it's a very, very far away thing. No? So they are representing that with a dotted line. The light is coming from far away. The same thing as the actually light will be going from everywhere. We are just considering few of them for, just to make sure that we are not making the diagram too messy. Okay, can all of you understand what is this dotted line over here? This dotted line, what is it? Yes, it's the normal. And we had learned while we were learning the rules, we learned that at the point of incidence, which is D over here, D is the point of incidence. If we want to draw the normal will always pass through the center of curvature. Okay, so this is the normal, the dotted line. And then the angle made by the incident light with the normal, that would be your angle of incidence, and lower part is the angle of reflection. So you don't need to show that for all the diagrams. You can just draw parallel light coming through the focus like that. Okay, if you are interested, if you have enough time, you can show that. This is following the law of reflection. So this angle you can call it as I. This angle here you can call it as R. Okay. So enough of the diagram. Now let's write down all the important information about this. What did we learn from this ray diagram? We learned that when the object is at infinity, what does the image look like? Image, there are three things to remember. Where is the position? Where is the image? That you can call it as the position
at focus.
Yes, very good. And then the next thing which we need to ask is, what is the size of the image? Is it small? Is it big? Is it as big as the object, bigger than the object, or smaller than the object? Those things we should ask, right? About the size of the image. Then third thing, we should ask the nature of the image. Anyone can explain? What is the nature of image?
Inverted.
Yes, inverted or real or virtual or erect, all those things. Real or inverted, virtual or erect. Those kind of things you call it as the nature of the image. Okay. So,
Sir,
yes, tell me.
so how will we know the size of it?
Size. See, the head of the object that also goes and meets at the focus, and the foot of the object that also goes and meets at the focus only. So what about the size of the head and toe? Both are exactly on this F itself. So how big do you think the object will be? It's a very small object. It's a point size object. Okay, that is what tells you. And if you see the other diagrams, it will make more sense. Right now, it might seem a little weird because head and toe, everything is going into the focus. So where is the image?
Sir, in the book they have given highly diminished. What does that mean?
Yes. Highly diminished means that's what? It's a point size object, very, very small. Diminished means small. Highly diminished means very, very small. And this point sized means it is actually on the focus. Head and toe both are lying on the focus on a single point. But if you really take a practically, if you take some mirror, it will not be exactly point size. It will be very, very small actually. Even if you try to project the image of a sun, you will see that there'll be some spot will be there. No? This big spot will be there at least. Have you ever tried to burn something, paper or something, with the help of a concave mirror or a lens at least?
Yes, sir.
Yeah. So the image of the sun is being formed at whatever place you want to. If you have taken a mirror and And if you take a piece of paper, if you focus all the light of the sun, everything will go and meet at the focus, because all the light from the sun is coming parallel because it's very, very far away. Everyone knows that, right? Sun is very far away, so all the light from the sun is parallel. In parallel light, if we align it with the principal axis, it will always go meet at the focus. And that image of the sun, that is also, when we call it as a point size because sun is very, very big, but the image of that is like as small as the sun, so small, right? That's why it's highly diminished. Okay. Fine. So position at the focus, size, highly diminished, which we also call it as point size for this one because it's as small as a single point. And the nature, even though this thing is not clear from this image, but you should understand that when you have a concave mirror and if the light is coming from very far away, it will be inverted image actually, okay, and it will be real because light is really going and meeting at this place. No? The reflected ray really goes and meets at this place. That's why this makes a real image. So real and inverted image. That is the nature. So everyone is clear with the first diagram? This should be very straightforward and easy to draw also. Parallel lines meeting at the focus. There is no confusion about drawing this ray diagram. Hopefully. Okay, so let's move on to the second ray diagram where the object will be at. The object
Beyond the sea.
Yes, we call that position as beyond sea. We had seen that in previous class. So we did with the first one. Now we are moving on to the second ray diagram, which is beyond sea, when the object is a little bit further. This ray diagram can be a little tricky to draw, so make sure all of you follow with me and see. Here, and is here. Like I said, take some comfortable distance, call it F, and take the exact same distance using a scale, call it as. So where should I keep my object now? It will be beyond sea, means somewhere away from the sea, but this time it will be close enough and I will be able to put this object in such a way that its foot is lying on the principal axis. I will keep the foot of the object on the principal axis. Remember guys, this is the principal axis is a straight line, okay, of course. Mistake. Consider that as a straight line. And the head of the object I will call as A, and the foot will be B. And everyone understands, right? I have told this to you. I'm drawing this as a stick or a, what do you call it? Arrow. But this object could be any object. It could be a person or a tree or object, anything. But for the simplicity, of course, this is not a drawing thing, right? Not a drawing class. So in physics, we are drawing it very simple, straight with an arrow. Represents an object AB. What should I do now, guys? I want the image of this object. So now in this case, what we do, we take one single point, focus on the one single point first. Let's start with the head and let's see where the image of the head will be found. and then we'll come to the foot of the object. So to find out where the image of head is formed, we need two light rays. Two light rays, and wherever the reflected light meets for those two rays, that will be the point where image will be formed. So if that made any sense to you people, did you understand what I said? I said two light rays I will take from here. Take for the light rays. So let me take this blue and I will draw parallel light. I told you that light will be going in all sort of direction, right? Whenever some object is there, light is going in all directions. But we are considering only a few of them. Specifically, we are considering only two of them at a time. So this is the first one. I'm throwing it parallel. Why am I throwing it parallel? Because I know that when I throw a light parallel, it will pass through where?
Focus.
Pass through. That is why I took the parallel light. Otherwise, I could have taken some other light also. The one which is reflected from. Now this is one light ray going there. What else can I do? Remember the rules which we studied?
Sir, another ray will pass through center of curvature.
See, it is up to us. We can do anything. We can make the light ray pass through the center of curvature, because we know what will happen when the light is going through the center of curvature, right? What will happen? Can anyone tell me?
Sir, it passes through center of curvature itself.
Yes, it will be reflected back in the same path. Okay, so it went like this and it will come back through the same path, reflected back. For me, it will be a little difficult to draw, but of course you will be using a scale, so it shouldn't be that bad for you, right? Now, tell me, where is the reflected light meeting again? Once, see, these two light rays, they started from the same position, but after reflection, they're meeting at some place. Can you see that that place is over here? Everyone can see that? This is the place where the reflected light meets again. They remember both of them started at the same place, but then, like two brothers, they separated and then they met back again at this point. So this is a place where the image of object A will be formed. So let's call that point as A dash. A is for the object, A dash or A prime, some people like to call it. A with a small dash on it, that will be the image of the head. Now, where will be my image of the foot? Foot will always lie on the principal axis. If the object had a foot on the principal axis, okay? So of course, we will be considering foot always on the principal axis. So we will just take a scale and we'll draw a line. Yes, tell me, anyone has a question?
I passed it through the focuser, then it will become, it will pass parallelly, so that point also we can take.
Absolutely, you can take. There is nothing wrong with doing that. You can make it go parallel, make it go through the focus, and then make it come parallel, and you will notice that it will meet exactly at the same point. Okay? It will meet exactly at the same point if we draw everything up to the scale. But of course, I'm doing this with hand, so it will not be exactly. We just rely on the drawing. But if you take everything to the scale, it will exactly meet at the same place. And you can consider any of the rays, doesn't matter. Even though in the book you might see some specific thing taken. Okay, so I have taken the same thing which is there in the book, but like I said, you can make it go parallel to not parallel. I mean to say, make it go through the focus, and it will come back like this, meeting at the same point.
Sir,
Yes, tell me.
can we make it go through P, sir?
Of course we can. But when you are drawing something with the, like, let's say you don't know where this point is meeting. If you don't know where it is going to meet, let me draw a rough figure for you. So let's say this is my thing, concave mirror, focus, center of curvature, object is here. I made the parallel light over here. I know it will go through the focus. Now, I don't know where it is meeting. So if you try to take this light to the pole, how do you make this line go? You will have to consider this exact angle, no? How much angle is over here? Now, is it easy to measure this angle? No, right? It will take some time, no?
Yes, sir.
So if you have a way to measure the angle, of course, you can take it through the pole also, and you will notice that that will also meet exactly at the same place where the other two lights were meeting. This or through the focus, all the light rays will meet at the same place. Okay, all of them will meet at the same place. But we just pick something which is easy to draw. So I think center of curvature thing is the easiest to draw. You'll get this thing very easily. A dash and B dash. Does that make sense to everyone?
Yes, sir.
I'm repeating this and so many times, and I'm telling you again and again. Remember, light all. Whenever you have some object kept in light is coming and getting reflected in all sorts of directions, not going only parallel or through the center of curvature or through the focus or pole. It's going everywhere. In between also light is going. But we don't want to do all that because it will be difficult. If I take some light which is just going somewhere over here, I will have to draw this normal, make it pass through the center of curvature, measure this angle, what is the angle of incidence, and then according to that, I will have to draw the angle of reflection and then make the reflected ray go. So the process will become complicated. That is the reason we are not choosing those rays of light. Okay, we are choosing the ones which are very easy to draw, like the parallel going through the focus or center of curvature getting reflected back through the same path, or even the focus and then going parallel. These things are easy to draw. That's why. Okay. All right. So your object, where is it? It is at A dash, and the foot of this object will be exactly parallel on the principal axis. Here you can call it as B dash. Okay. And just draw a ray.
Sir,
Yes, tell me.
so the more farther the object is from the center of curvature, the closer it will be reflected to the focus.
Yes, absolutely. Try to understand that when it was at infinity, the image was at focus, no? So as you are coming closer, the image is moving further away from the focus. So if you are further away, image will be closer to the focus. And if you somehow come very, very close to the center of curvature, your image will also be very close to the center of curvature. Is it clear?
Yes, sir.
So the light rays from B is going towards the pole, and you know that pole, this will act as a normal. So the reflected ray will come back again through the same principal axis only, right? That is why the reflected ray from B will always meet at this B dash somewhere on the principal axis only. And it will be straight. So we are just drawing straight line A dash B dash. Okay, let's write the information about the image. The three things we need to consider.
Position, size, nature.
Yes, position, size, nature. So you people tell me this time, where is the position of image this time?
Between C and F.
Yes, the image will be between C and center of curvature and focus. What about the size? Just by looking at this rough diagram also, it might give you some sense whether is it smaller than the object or bigger. What do you think?
Small, sir.
Smaller.
Yes, it is smaller than the object. And also notice one thing. If if you keep coming closer to the center of curvature, the closer you are to the center of curvature, the image will get bigger and bigger, and it will be as big as the object when it exactly, if you put the object at the center of curvature, the image will also come at the center of curvature and they both will become same size. I want you to remember the flow of this thing also. Like as you are moving closer, image gets bigger and bigger, and it will get as big as the object when you put the object at the center of curvature. Tell me, all of you, is that idea clear to you? How that image is changing as we go closer to the mirror or closer to the center of curvature as of now?
Yes, sir.
Size of the object, the size of image will be still smaller than the object, which you can call it as simply diminished, as you can see the word over here. We'll just call it as diminished, means it is smaller than the object. Okay. Nature, you tell me, is it a real image or virtual image?
Real.
It is a real image. Why is it a real image? Because the light rays which were reflected from the mirror, they really go and meet at A dash. Actually, they meet. Okay. That is why this is a real image. And there is one more property of a real image, that real images can be projected on a screen. So if you put some screen over there, you will be able to see that object actually on that screen. Okay. Real objects can be projected on the screen. If you put some kind of screen over there, you will be actually able to see the figure or the image of that thing. So it is real. And what else? Is it inverted or erect? What does it look like looking at the object?
Inverted.
Inverted.
It is inverted. Okay. Whenever you have a concave mirror, with most of the cases, object will be real and inverted, except for one case which we'll see. That's okay. Fine. So 2 cases. We are done with that. Let's move on to the third one. What should be the third case, guys? Where is the object now?
At center of curvature.
Yes. At center of curvature. That is at C. So try to draw along with me. Maybe you can try to draw faster than me. Okay. So now I'm going to put the object exactly at C. And I'm going to call it as AB. So this is A. What should I do now, guys? How should I throw the light? Again, we'll consider one point at a time. A, the head. I'll throw the light parallel. Parallel light will pass through. Yes. What else should I do now? One light ray I have taken parallel and went through the focus.
the other one will go through focus, the incident ray.
Yes, it will go through the, let's make the light go through the focus, and the reflected ray will be parallel to the principal axis.
So we can also make another ray go, like the point of incidence will be pole for it.
Yes, like I said, you can
And
do
also
that.
it can be same.
Can do that. Okay, that's your choice. You can do that, but if you do that, you will have to draw the reflected ray in such a way that it goes and meets at the center of curvature like that. A little difficult to draw. That's why I'm taking this one. See, there is a problem while drawing this kind of figure. So what you do, I'll show you how to cheat. I know that when I keep my object at this place, center of curvature, I very well know that the image is going to be at the center of curvature only. I know it. And I also know one more thing, that this image size is going to be exactly same as that of the object. So what you do, you draw the image and you draw the object also approximately same size. So let's say you took this as 2 centimeter, you draw this also as 2 centimeter using a scale. Take a scale and draw one full straight line from here to here like that. 2 centimeter up, 2 centimeter down. Everyone is okay with that? Now you take your pencil, draw parallel lines, you draw this line, incident ray, which I have drawn earlier. And you also draw this line down here. Before itself you draw. I know that it's going to meet at this place. Don't even put this focus. Make your light meet over here. Somehow, magically, this guy also meets at this place. So this is how you will cheat. Means draw the line correctly. Now you call this point wherever they met, that point you can call it as focus. Did you people understand how I'm asking you to draw? Are you able to draw this on your notebook? Anyone is having trouble meeting all that? Drawing all that, let me know where you are stuck. Guys, are you there?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so everyone is able to draw this.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so what's the position? Tell me.
At center of curvature.
Yes, the position is at center of curvature. See, size
Same.
Same.
same as the object. Excellent. What about the nature?
Real.
Real, because light is
Real
reflected
and
right now.
water.
So as you can see, there is a repeated pattern. Once you understand how to draw this, this will not be like 6 different diagrams. They all have very much similarity between them. Okay. So we will stop here with these 3 ray diagrams, and I want all of you to make sure that you have all this in your notebook and you understand what's happening in these ray diagrams. You should be able to draw it very fast. And not just draw it, you have to practice it so that you can draw these ray diagrams fast enough. should not take 10 minutes to draw this in your exam when you get this board exam. Okay, so all of you practice this. Anyone has any questions? Say this, what we studied.